Welcome back. Today we're going to be talking about polynomials, and you'll be able to classify them, write them in standard form, and evaluate polynomial expressions. So I'm going to warn you today that there are quite a lot of notes to be taking. There's a lot of vocabulary in this video, and you will be responsible for all of this vocabulary. So please be sure to take good notes today. So the first definition is of a monomial. That's a number, a variable, or a product of numbers and variables with whole number exponents. So I'm going to show you some examples of monomials and then some non-examples. Here's an example of a constant, that is a monomial. I've got a single variable, the monomial. This is the product of variables, also a monomial, product of variables and numbers actually. And here's the product of a variable. It is raised to a whole number exponent, so I'm okay with that being a monomial. But here's some non-examples. In this first case, I have raised this variable to a negative power, so that is not a monomial. Remember, I have to have whole number exponents. Negative numbers are not whole numbers. And I've got two terms in this expression, so this is not a monomial. And here I've got a exponent in the denominator, which means I in fact have a negative exponent, so that is also not a monomial. So the next thing you need to know is what the degree is of a monomial, and the degree is the sum of the exponents of the variables. So if I have a constant, that's a degree of 0. Remember, anything raised to the 0 is 1, but in this case I'm looking at any constant, and that has a degree of 0. I'm going to find the degree of each of these monomials. Here I have a exponent of 4 and an exponent of 3. I'm going to add those together to give me a degree of 7. Here I've got a degree of 1, single variable, no exponent. I don't see an exponent, but I of course understand that to be a 1. Here I've got 2 variables raised to the first power, so that is a degree of 2. Here I've got a degree of 4. And finally, remember, a constant is a degree of 0. Okay, so another definition. A polynomial then is a monomial or a sum or difference of monomials. So here are some examples of polynomials. I've got a straight up monomial. Here I've got a sum of monomials. Here I've got a difference of monomials. Yes, in fact, we will see shortly that a polynomial can have many, many terms. In this case, I just have two-term polynomials, and we'll talk about how to come up with a name for that in a moment. So, definition. The degree of a polynomial is the degree of the term with the greatest degree. So we just determined how to come up with the degree of a monomial. Now we're going to identify which monomial I want to find the degree of in my polynomial. So we're going to find the degree of this polynomial. Notice I'm looking for the one with the greatest degree. Well, that's going to be right here. I've got a variable raised to the 5th power, so my degree for this polynomial is 5. Of all of the terms in this polynomial, the highest one is 6, so that is the degree for my entire polynomial. Here I'm going to have a degree of 1 because this variable has just a exponent of 1, and this one, remember, is a 0, so the highest one is a degree of 1. And lastly, this one looks a little more confusing because I've got multiple exponents. Remember, I'm going to add these two together to get the degree of this monomial. So this is a degree of 5. This is a degree of 5. This is 4. So the highest is going to be 5. All right, so I can write the terms of a polynomial in any order. However, I'm going to expect you to write them in standard form, and to write them in standard form, I'm going to ask you to write them in order from greatest degree to least degree. So the highest degree is going to come first in standard form. Okay, when it's written in standard form, then the coefficient of the first term is called the leading coefficient. It's the one that leads, it starts out. So we're going to be able to write a polynomial in standard form and name the leading coefficient. Here's our example. Notice I've got 4 terms in this polynomial. This one's the highest, so that one's going to go first. Negative 7x to the 5th. Next highest is going to be my x squared term. Then I've got a straight up x term, and finally my constant. And my leading coefficient then is the coefficient out here in front of my highest degree term, and that's going to be negative 7. All right, so you can try these out. Pause your video for a second and come up with the standard form and leading coefficient. Notice my leading coefficient is -1. Okay, I've got that negative tacked out there. Okay, so there's going to be a lot of notes on this page. Be prepared. Some polynomials have special names based on their degree and the number of terms they have. We're going to go through the degree part first. So here I've got the degrees listed, what the degree is of, remember, the highest term in our polynomial. If my highest degree is 0, then I've got a constant. If I have, so that's going to be any number, right? 5, 7, whatever it might be. If I've got a degree of 1, that's going to be a linear expression, and that's going to be something like 2x plus 1. A quadratic is what we're about to move into, and that's when I have a degree of 2, so 2x squared minus 3x plus 1. Cubic is going to have a degree of 3. A quartic is a degree of 4. Quintic is a degree of 5. After we hit 5, we just call it by the number of the degree. So 6th degree, 7th degree, 12th degree, whatever it might be. The ones we are going to be looking at most frequently are these right here. We've been studying linear since the beginning of this year. We're about to move into quadratics. And while we won't study cubics, you'll be expected to know the definitions of all of these and be able to identify a polynomial by its degree. Second part we need to do identify is by the number of terms, and we've only got a few of these. If a polynomial only has one term, as we discovered at the beginning of the video, it's a monomial. A 2-term polynomial is called a binomial. 3 terms is trinomial, same prefixes as you're used to. Anytime it's 4 or more, that's just going to be a polynomial. So let's look at some examples of identifying by degree and by term. I'll do this one with you. My highest degree here is a 3, already written in standard form, so it's easy for me to determine what the degree is. So I've got a degree of 3 and I've got 4 terms there. That means I have a cubic, go back to your notes, a cubic polynomial. Too many terms to have a special name beyond that. Polynomial. Okay, go ahead and pause for a second, come up with these. 6 degrees, 3 terms, makes it a 6th degree trinomial. And 0 degree, 1 term, makes it a constant monomial. Okay, So, of course, I have to have a real world example here. So, we're looking at a firework. It is launched from a platform that is already 6 feet above the ground. It's going to be launched at a speed of 300 feet per second. So, if it's got a 5-second fuse, I want to know how long before it explodes. Well, here's the height of the firework at any time based on the number of seconds. T is seconds. The number of time since it has been lit. So I'm going to substitute in my 5 seconds for my t because that's when I know it's going to explode. So I'm just going to substitute in 5 for t. I've got negative 16. 5 is going to be squared plus 300 times 5 plus 6. Remember, this is a quadratic equation. We're going to get to see lots of these pretty soon. And it is a quadratic trinomial. It has 3 terms. So I'm going to go ahead and evaluate this. I've got negative 16 times 25, 5 squared. So I've got negative 400 plus 300 times 500 is 1500 plus 6. So that's 1100 plus 6. So at 1106 feet, my firework will explode. Okay, so here are just some examples for you to run through. These are in your notes, but you're going to show them to me tomorrow. I'm looking to see how well we understand the degree of each of these polynomials. I just need you to identify the degree. Here, I want you to write it in standard form and tell me the leading coefficient. Give me both of those things. And here, you're going to classify the polynomial according to degree and the number of terms.